I'm servicing my planer thicknesser, and it's a job I absolutely hate, but it has to be done from time to time, doesn't it? This is quite a long film, so grab yourself a brew and a sandwich and settle down. Welcome to Workshop Essentials. We'll start with just a brief word about terminology, because it's different depending on whether you're in the UK or in America. In the UK, we call this a planer thicknesser, and this top bit is the planer, more traditionally a surface planer, but these days it's called a planer. And the bit that goes underneath is called a thicknesser. And in America, you will know this as a jointer, and you would call that bit the planer. And that's the confusing bit, because we use the word planer to mean two different machines, depending on which side of the pond you're on. So to me, this is a planer and a thicknesser, and those are the terms that I shall be using. It doesn't matter, just so long as we do understand each other. Okay. The machine itself works with a motor, belts, pulleys, chains, cogs. So if we have a look at the mechanism, it will help us to understand how this thing works, and then we can set it up knowing what bit does what. So let me just turn this round. So here we've got the main drive pulley at the bottom, driving a fan belt, which directly drives the cutter block. And the pulley up here is smaller than this one, so it increases the speed. So this is round at about, I think it's about 5,000 RPM. We've then got another drive belt which comes off that, and that's only about an inch or so, 25 millimeters in diameter, that pulley. It's very small, and it drives this great big one here, which is about 200 mil in diameter, 8 inches or so. And so this goes round much more slowly. And then that in turn reduces the speed further with this bicycle chain arrangement, which goes round these two cogs here, and these are the ones that drive the feed rollers. So it ends up with the feed rollers going much more slowly than the main cutter head. So it feeds through at a sensible rate while the cutters are whizzing around doing all the cutting. I'm keeping well away from this. So now I'll just put the side panel back on, because I don't like leaving it exposed, even when it's not plugged in. This is a modification I wish I'd made years ago. I've just built a sort of bracket onto the back, so that when I'm not using the fence, I've got somewhere to put it where it's not in the way. Before we even start thinking about installing the knives, we need to make sure that the tables are right. Because if the tables are not right, it doesn't matter how sharp your knives are, you're going to get poor results. So a machine like this has two tables, an in-feed table and an out-feed table, and they have to be aligned with each other correctly. So we don't want them to be twisted like that. We don't want a hill like that, with this as the high spot. And we most definitely do not want a valley with this as the low spot. So the first thing to do is to check that they're not twisted. In woodwork we call that wind. And so I've got some winding sticks. These are made out of walnut. And I've got a maple inlay there. And they work by exaggerating any twist that's there. So this goes at this end with the white strip facing me. And this goes at this end. And I stand back here and look down, and I'm checking to see if both ends of that white strip disappear at the same time, or whether one disappears before the other. And I'm delighted to say that they both disappear at exactly the same time, and that means my tables are not twisted. If they are twisted, you're going to have to adjust one or the other. We'll talk about adjusting in a moment. And the other test is for planarity. So you need a straight edge, ideally a ground engineer's straight edge. I don't have one. I don't know anybody who does that I can borrow from. So I'm using my spirit level. It's not ideal. It's not ideal, but it's the best I've got. So that goes on the outfeed table. And you also need some feeler gauges. This is a metric set. These are in thou. It really doesn't matter because we're not measuring absolute values. We're just looking for any differences. So hold that down and just feel what sort of a gap you've got there compared with there. And if it feels the same, that feels a bit sloppy. Let's wind it up a bit. That feels about the same to me. I know that this table is not perfect, but this is the best I can get it. And it works. The bottom line is that I get good results with it. If you've got a fancy machine with adjusters, adjust them and spend some time getting it perfect. But this is very crude. The tables are bolted to the chassis, 3 bolts on this side, 3 bolts on that side, and that is it. So in order to alter it, you have to slacken off these bolts and use a persuader, up or down, and then tighten the bolts again. And it's as crude as that. But I get perfectly satisfactory results, so I'm not complaining too much about that. Only when you've got the tables right can we start thinking about the blades. When you get a new set of knives, they will arrive straight and sharp, won't they? Well, it depends what you mean by sharp. They will usually come ground, and a ground surface is fine, but it's not as good as a honed surface. So you might want to consider making yourself a little gadget like this. It's just a block of wood with 2 saw cuts in it, cuts to mount the blades at the angle of your grind, or a degree or 2 higher, not lower, otherwise you'll just be grinding the heel of the bevel rather than the edge. And your knives go into there like that, so the bevels end up flat. Just tighten it up. And I've got a piece of emery paper glued to a piece of glass, some WD-40, and a few strokes is all it takes to get rid of those grinding marks and leave you with a nicely polished edge. But of course, it's not only the bevel that matters in getting a sharp edge, is it? We have to think about the back as well, because it takes 2 faces to make an edge. So if you have a look at the back, if you're lucky, that will be nicely finished, and if you're not, you might also have to just try and keep the pressure evenly on the edge. I'll have to think of a gadget to do this more successfully, maybe some rare earth magnets mounted in a block. And that will just clean up that very edge there, leaving me with a very sharp cutting edge. That looks rather good, actually, and that's the ones that come off. If your cutter block has 3 knives in it, you can still use a jig like this. Simply hone 1 and 2 together, 2 and 3 together, and then 1 and 3 together. And if you use the same number of strokes each time, they'll stay balanced. This is a blade off a bigger machine than this. This is a 12-inch blade. And it's at the end of its life. This blade really needs, it doesn't just need honing, this needs regrinding. And we can see what happens to a blade when it gets worn. I've got a little magnifier on my camera, there like that. And if I run this along, you can see what this blade looks like. You can see why it was time to change the blade. And compare that with a brand new blade, and you can see that it is much, much better. all the way along. Beautiful. Beautiful, that. So I've got 2 blades ready to go in, and we put them in one at a time. We don't take them both out and then try and put both in. We do one at a time. So the first thing then is to make sure it's unplugged, obviously, and undo the bolts that hold the knife in. Now, by undoing on this, we actually tighten them up because it's the head pushing against the back wall of the slot that's the that gives it the pressure. So that comes off. There we go. Still a bit tight on this one. There we go. And that's ready to go off to the saw doctors. And I can see, just by holding it up, that there's 1 or 2 nicks in it. I've hit something harder than I would like, either knots or... I don't do much reclaimed stuff on here, so it's probably not a nail, but that's not in great shape. And I have swapped the springs on this. So if we just take the clamping bar out, there we go. Now, this machine originally had little tiny coil springs underneath the knives, and they were forever lasting, getting lost. So I got rid of them, and I've made my own springs instead, which are like a sort of flattened question mark. And they're made from the inside of a windscreen wiper blade, which is a spring steel. It's perfect for jobs like this. Bit of a clean out, and they just sit in the little holes that house the coil springs, and they're much more difficult to lose, actually. Then the clamping bar goes in. If this is badly crudded up, then clean all this stuff off, but this isn't actually too bad. There's a little bit, but that's not so bad. And make sure that screws are in as far as they go, pretty much. And that goes in there, and that will leave me a gap big enough to put my planer blade in, right over those springs. So now with the springs and the pressure bar in, it's time to fit one of our knives. And it's a good idea to remember which way they're rotating so that you don't put them in back to front. But obviously the sharp edge is coming towards me. And they sit in the gap between the pressure bar and the cutter block. And the cutter block is the bit that defines the cutting angle. The grind angle is pretty much irrelevant, actually. It just gives you clearance. Originally, these was done at 40, but I think the firm that sharpens them now sharpens them at 45 degrees. It does matter if you're going to do your honing. And I can feel that they are sitting on the springs. There's some spring-loaded movement there and there, which is what we want. Jolly good. So the idea is to get them so that they are a fraction above the outfeed table. And by a fraction, I mean a thousandth or so. And the reason is that the cutter block, when it's rotating, is taking out circular bites out of the wood, like this. Okay, one blade comes along, takes a bit out as the wood is moving forward, and then the next knife comes along and takes a bit out, and the next one. And so you end up with a rippled surface like that. And this is not a theoretical rippled surface. This is a real measurable distance here. And I think you can see that the camera just picks up those ridges. If I run some chalk on it, it makes them much clearer. And that's also why when we put a hand plane to a freshly machined surface, we don't get a proper shaving. The first pass always produces, well, dust really, look, red dust from the... And that's because all we're doing is taking the tops off those ridges. Only when we get past there do we get a proper shaving. And it feels so much nicer. And so if you have the outfeed table set at the top dead centre of the knives, which is here, then these bits here, the sharp bits that are left, they will foul the outfeed table. Because we want, when it comes off, to keep it level, it's these points that we want sitting on the table, not the tops of the scallops. Okay, we want it to sit like that. And so that difference between the pointy bits and the tops of the circular cutout, that's the amount by which the knives need to be higher than the outfeed table. And traditionally, you can do it with a dial test indicator, but I've never had a lot of joy with those, actually. It seems to be wander about too much. This one I'm looking for. The traditional way is with a block of wood, and it needs one flat face, and we're looking to drag this block of wood by the same amount at both ends of the blade and on both blades. And it will vary on machines, but usually it's about 4 millimeters, 3/16 of an inch, something like that. Something like that. So let's make a start. We'll get one end in first, push it down, and we'll just undo that bolt so that the head jacks against the back of the slot there. And the same at this end. And then we'll see what we've got and how much we've got to move it. Mind your skin on this, of course, they're sharp. Right, that's in. Whether it's right or not remains to be seen. Let's see how much it moves when we try to do a drag test. Well, that's way too much. Look, that's moving 3/4 of an inch, which means that that's got to go in. That's got to go in quite a lot. So we need a block of wood. May as well use this, actually. And a mallet. And we're just going to tap it and try again. Better. Better. Okay, still too much, but better. If you need to bring the knives up, that's more problematic. It's not so bad on a machine that has lifters, little screws that fit into slots like this. You undo the screw and it pulls the blade up. But this machine does not have lifters. So tapping the blade down is one thing, lifting it up is more difficult. So to do that, we get a piece of metal, and instead of tapping the blade, we tap the wedge. And that releases the knife just enough for it to be pushed up by those springs a little tiny amount. And that way, we've got control over the height of the blades. Now, to get a more accurate reading, I like to put a piece of masking tape on my table, like that, and that way I can line it up with the masking tape there and see how far it goes. So that's actually about right. There now. And on this side, again, start at the masking tape. Now, I would say that was right. Now, when you come to use a machine like this in anger, there are a couple of things to bear in mind. And the first is that these knives are travelling at almost 50 miles an hour, right? And at 6,100 revolutions per minute and 2 blades on it, it means that if I make contact with that for just 1/10 of 1 second, I'm going to get 20 lacerations at 50 miles an hour each. So bear that in mind the next time you even consider using it without a guard on. Okay, I don't want to see any unguarded blades. And we never plane without the fence either. Even if I'm not actually using the fence, it acts as a guard behind where it is. So that end of the table, that side of the table, is guarded by this here. If you're in America, you'll be more familiar with pork chop guards probably, but we don't tend to have them on machines here. We have a bridge guard like this. This one saw a bit of damage. This head that holds it is only held in place by a pin. And one day the pin worked its way loose and this fell into the blade and yellow stuff everywhere. Fortunately, there was only yellow stuff everywhere. There wasn't any red stuff anywhere. But it was a bit of a shock. And I've just sort of mended it with hot melt glue. I really ought to find some way of replacing this. So that goes in there like that. And there's 2 ways of setting this up. It can either be low down with a gap behind there, and that's the way I use it if I'm doing a narrow edge like this, with the guard up to the workpiece, so that this is covered very low down. But for a wider piece, a wider face, I don't want to have it like this, because at the end of the cut, there's a lot of cutter exposed there. So for something like that, the guard goes right up to the fence, and instead it's lifted up, leaving me just enough room to get my workpiece through underneath like that, and it's still guarded even at the end of my cut. The technique for pushing something through, I have to say I'm not as assiduous as this as I ought to be, but the right way to do it is to start here and push onto the outfeed table, and then when it's registered on the outfeed table, change your grip so you're pushing down on the outfeed table and forward on here, and then before this gets to the cutter block, change grip again, both hands on the outfeed table, and push off like that. What you don't want to be doing is risking getting the heel of your hand at the end of the cut, like that, or your thumb at the end of the cut, like that. That's what we're trying to avoid. So by the time it gets to there, both hands should be on the outfeed table, like that. I don't often use a push stick on the planing thicknesser, but I do if I'm having to plane something a fairly small section like this. If it was something that was this small, this low, then I would be using a push stick like this at the end of the cut. Okay, just to make sure that the heel of my hand doesn't come anywhere near that cutter block. Right, well, I think it's time to give this a whirl. And I'm delighted to say that that is perfect. If you noticed, it didn't catch as it reached the outfeed table. It didn't catch on that front edge, which means that the table is not too high. And there is no snipe at the back end either, which means that the table isn't too low. It is absolutely right, and this is now set up for me to do a very nice job of all the oak I've got to repair for my next project. If you've got both knives set right with respect to each other, but it's catching or you're getting snipe, if the end result isn't perfect, it's not the end of the world. We can adjust it by altering the outfeed table. And on this machine, that's done by unlocking a screw in there, and then alter the height of this, screwing it in moves it up, and that will reduce snipe, and moving it back lowers it, and that will stop your workpiece from catching. But if it's right, as it is with this one, you don't need to adjust that. So we'll just tighten that up again and say we've never seen it. There we go. There are times when you need to be able to move the machine about, and it's very tempting just to get hold of it, me at one end, a mate at the other, pick it up and move it to where it needs to go. It's not a great way to treat these machines because we've already discussed how easy it is for these tables to go out of alignment. So this is what you do. In thicknessing mode, take a big strong board like this, and you put it inside so it sticks out about the same each side, and tighten up the thicknessing table. Like that. And now you've got something to get hold of. And all the weight is being taken by the rollers. Like that. There's no strain being put on the tables whatsoever. That's how to do it. Of course, surface planing timber is only one of the tasks that this machine will do. The other is to thickness it to uniform size. And to do that, we have to convert from one mode to the other. So the blade comes off and gets stored. The fence comes off and gets stored. The outfeed table lifts up. And you have to wind the table right down to the bottom. I've already done that. It's a bit of a pain, really, when if you've just been thicknessing up here somewhere, you have to wind it all the way down. And then the hood swings over, and then you have to wind the table back up to whichever dimension you want. Let's remind ourselves how this actually works. Now, as you will recall, we've got the cutter block in the middle, rotating in this direction. And we've got an in-feed roller over here, which is serrated and grabs the wood. And we've got a smooth outfeed roller over here. And these two rollers work against the cutter block. And these are spring-loaded, which means they can move. They can yield. When you apply pressure to them, they can move upwards, and that can be a problem if we're not careful. Here's my workpiece, and the workpiece gets fed over from this side, and it goes underneath the feed roller, underneath the cutter block, and then underneath the outfeed roller. And at that point, it's held down by both rollers. Nicely balanced, lots of pressure. And that happens until we get to about here. And then, all of a sudden, there is no pressure on this end. Once it clears that in-feed roller, there is no pressure on this end. There is only pressure on here. The amount of pressure has been halved instantly. And that means there's a lot of force on this roller, which is spring-loaded, can move. So as this comes off the in-feed roller, the weight, where I'm holding it, pushes down. The outfeed roller gives way a little bit, it yields on its springs, and these last few inches of my workpiece end up going into the cutter block more than they should. And that's how we get snipe. So we have to find a way of preventing that from happening. So let's see if we can force this machine to produce snipe. Press the wrong buttons for a minute. Well, I pushed down on that as it came through, and I can feel that snipe there. And if I run a pencil on it, you'll be able to see it yourself. It's right along there. And that's because the outfeed roller gave way as I pushed down, and the infeed roller was no longer pushing down. All the pressure went on the outfeed roller, which moved upwards, and it allowed that last few inches to be pushed further into the cutter block. So the solution is simple. We just support it on the way out. Snipe? What snipe? That is perfectly smooth right to the very end. A bit of support, it makes all the difference. When you successfully thickness your wood, measure it and then make sure that your cursor reads exactly the same value. And if it doesn't, you can usually adjust it up and down so that it reads the same as reality. I've had this machine nearly 20 years, And when it first arrived, it was a really bad Friday afternoon job. There were lots of things wrong with it. The paint was already peeling off. I mean, this here isn't old age. It was like that pretty much straight out of the factory. But there were lots of things wrong about the way that it worked. And one of them was that I was getting a lot of marks in the timber after it had been planed. Marks from the infeed roller, the serrated infeed roller. If that happens to you, you might find that you've got them on one side of the board and not the other. And that's a telltale sign that you've got a problem with the tension on your springs. So this is what you do. You have to take bits of it off, so I can't show you. But you remove the dust cap where the springs are, stick in either a spanner or an Allen key, depending on what it requires, and just adjust the tension on the springs. Just slacken them off where you're getting those marks, and then put the dust cover back on. You want to have it so that there is enough tension to feed the wood through, but not so much that it's marring the finished surface. Another thing that was wrong with this when it was new was that thicknessed wood would come out with different dimensions along one edge than on the other. There was a millimetre, nearly a millimetre difference over a piece that was only 5 inches wide. So no, that's no use to me. So I rang up and complained, and they sent out an engineer. And he took one look at it and he said, "Oh, what's one of those?" Which did not fill me with confidence. And I said so. He said, "Well, I've never seen one of those, but up until last week I was servicing Chinook helicopters." Okay, so I kind of reset my opinion of him then. He tried to fix everything, couldn't do so, took it away. It came back 3 weeks later, perfect, absolutely perfect. And he billed them for 16 hours labour. Now, 16 hours of a professional engineer would almost certainly be more than what the machine cost in the first place. One of the things he had to do was to alter the thicknessing bed so that the wood came out parallel. There are 4 lead screws which make the thicknessing bed rise and fall as I turn that handle. And where you can't see, there are 4 cogs on the ends of those lead screws, like that. And they're all joined by a chain so that as the chain goes round, all the cogs go round at the same rate and the table goes up and down at all 4 corners by the same amount. The problem is if one corner is higher than the other or one edge is higher than the other, you will get this kind of problem. So what you have to do is take the chain off and then move the offending cog by 1 tooth and put the chain back and try it again. And if that's not enough, you've got to do it by another tooth until you're getting a piece that's parallel and not tapered like this. I'm glad I didn't have to do that. I really am, because it's not an easy thing to do. So all that remains is a bit of lubricant on those lead screws and a bit of paste wax on the tables. And now, she's good for another couple of projects, I reckon. Well, that was a bit of a marathon, wasn't it? Thank you for sticking with it. If you've enjoyed it, please remember to like, subscribe and share. It really makes a difference. It matters. It's the only way these films get seen when people do that. And if you've got any questions or comments, leave them down below. I do read them all, and if they require an answer, and I can answer them, I do. So I've done my job, that bit's your job. Thank you very much for watching. Until the next time, enjoy your workshop. Cheerio!